In this video, we're going to be talking about the square root property, or the principle of square roots, as it's also called. It says that if b is a real number, and if a squared equals b, then a equals positive or negative square root of b. So there's actually two solutions. For example, if I had x squared equals 9. Well, the question is, what could I plug in for x that would make this equation true? Well, 3 squared is equal to 9, so x could be 3, but also negative 3 squared equals 9, so x could be negative 3. Hence, when we take the square root of both sides of that equation, we have to consider the positive, the principal root, and the negative root. So the square root of 9 is 3, and then the negative square root of 9 is negative 3. So there's going to be two solutions when we use this square root principle. Alright, so to use this principle, we can use it on particular types of equations. The way we can identify those equations is if we have a squared term and no other x terms or variables floating around. For example, here I have x squared, but I don't see x. There's only an x squared. There's a quantity squared, and then there's no other x values here. So the way we're going to solve this is we're going to isolate that x squared term first, meaning I need to get rid of this 55, add it to both sides of the equation. Now I have 5x squared equals 55, and then I undo this multiplication with division, divide both sides by 5, and x squared equals 11. Then from there, once the squared term is isolated, I can use that square root property, meaning take the square root of both sides of my equation, and x, so the square root of x squared is x, equals positive or negative square root of 11. Sometimes I'll write it here so I don't forget it. So on your homework, you might be able to enter it this way with that plus minus sign, but if you can't find that plus minus sign, it might want you to enter the two separate answers, meaning the positive square root of 11 and the negative square root of 11. If it doesn't ask for a decimal, then you're going to leave it in that exact form. Otherwise, you'll round it to wherever you're asked to round things. Alright, so let's try this next one. Now, the next one here, sometimes students have the urge to multiply that out, but you don't actually have to. We have a quantity squared equaling a constant. So we can use that square root property here because we already have something squared equaling a number. So I can take the square root of both sides of my equation because it's already isolated, and the square root of something squared, I'll have 2x plus 3, or itself, equals positive or negative square root of 10. And now the goal is to get x alone, so we actually have to still solve for x. I'll subtract 3 from both sides, and the question becomes, where does that plus and minus go? So I'll see students try to put it with that negative 3, but this is only subtracting 3. There is no plus 3, it's only subtracting 3. So these are separate things. They're not like terms. They can't be added or subtracted. So all I'm going to do is, actually erase this plus 3 here. And all I'm going to do is just write minus 3 plus or minus the square root of 10, right? That plus and minus only goes with the square root of 10. And that 3 was just being subtracted. There was no plus 3. And then lastly, I divide everything on both sides by 2. And x equals negative 3 plus or minus the square root of 10, all divided by 2. You could also rewrite that as negative 3 halves plus or minus the square root of 10 divided by 2. Some textbooks will prefer that. You might also have it just broken up into the two solutions. So negative 3 plus the square root of 10 all over 2, comma, negative 3 minus the square root of 10 all over 2. So with all these, again, there's going to be the two solutions that we can separate with a comma. I'm thinking most likely this is how your homework will want you to enter that answer. Why don't you go ahead and try the 3 on the right. Alright, here we are at this example on the right. Again, I look through it and I see I've got a couple x squared terms, but there's no x term. So I can use the square root principle here. So I want to gather my like terms on the same side of the equation. I'm going to start by adding 2x to both sides to gather the x squareds. And if I move my x squareds to the left, I'm going to move my constant over to the right. So that's 0, that's 0. 3x squared plus 2x squared is 5x squared. And 13 plus 7 is 20. And then I'm going to divide both sides by 5 to get that x squared term alone. And I have x squared equals 4. So I'm going to use my square root property, take the square root of both sides. I'm not going to forget to do the positive and negative solution here. So on the left hand side, the square root of x squared is x. On the right hand side, the square root of 4 is 2, but I have the two solutions, positive and negative, meaning x could be 2 or negative 2. Alright, down here in the middle, we've got that whole quantity, x plus 2 squared equaling a constant. If it wasn't isolated, I would need to isolate it, but it already is all by itself on one side. So I can take the square root of both sides of my equation here. The square root of that quantity squared is itself x plus 2. And then on the right hand side, I have the square root of 18. I'm not going to forget my positive and negative solutions. But the square root of 18 can be simplified. That radical of 18. 18 is the same thing as 9 times 2. And 9 is that perfect square. So we can take out the square root of 9. Square root of 9 is 3. And then there's that 2 left underneath the radical. And then lastly, we want to get x alone. So I'm going to subtract 2 from both sides. And again, that plus and minus only goes with the 3 square root of 2. And notice when the 3 comes out, it's multiply. So these are stuck together here. It's not going to become 3 plus or minus the square root of 2. It's 3 times the square root of 2. So that plus and minus still stays out in front of that whole quantity here. And I'm subtracting 2 from both sides. And it's just going to stay negative 2 plus or minus 3 square root 2. They're not like terms. You cannot add them. You cannot add this negative 2 and 3 because it is being multiplied by that radical. So you cannot add these. They're not like. And if you needed to break it up into the two solutions, you could write it as negative 2, so it's still negative because we subtracted that, plus 3 square root 2, or negative 2 still, that's not changing signs, minus 3 square root 2. The only thing that gets that plus and minus is the radical part. And there you go. Alright, I've got one more here. Again, our squared quantity is already isolated, so I can jump right into my square root property, square root of both sides. The square root of something squared on the left-hand side is itself. On the right-hand side, I have plus and minus the square root of negative 4. So I'm taking a moment to analyze that. We learned in previous sections that the square root of a negative number, right, square root of negative 1 is I. And now that we know that, we're going to use that when we simplify. So I have plus and minus. The square root of 4 is 2. And the square root of negative 1 is I. And now I need to solve for x. I add 1 to both sides. I have 3x equals positive 1 plus or minus 2i. And then these are not like, you cannot add them. Divide by 3, everything gets divided by 3. So I have 1 plus or minus 2i all divided by 3, which I could write that as the 2 solutions of 1 plus 2i over 3, or 1 minus 2i over 3. Oops. And then sometimes, if your homework asks for it, it might want you to write the final answer in the form a plus bi. So if you ever see that, you might have to write it as 1/3 plus 2/3 I, right? So just breaking up this quantity, dividing everything by 3 across that sum. And then same thing with the negative solution, 1/3 minus 2/3 I. So just make sure you're paying attention to the directions on how you're supposed to write that final answer.